My name is Larry Mead. I'm a principal program manager with Azure Global Engineering, and I have Bob Ellsworth, who's the director of mainframe transformation at Microsoft. We'll go into intros a little bit in more detail in a minute, but what I wanted to do is just tell you what we're going to talk about. So we do have intros. I want to talk about the platforms we cover because quite frankly, mainframe is a term that can mean a lot of things to a lot of people. So we'll go into more detail what we mean when we say mainframe and what that means in trying to transform that. And we do use the word transform typically rather than migrate these days into Azure. And also, not everyone does things the same way. So we have different types of transformations and goals that need to happen. And what we want to do is look at different approaches based on those goals and options that are available. And that's where we get into the transformation details. And once all that's done, we've got some summary information, which basically goes through some customer scenarios of transformations. Now, we're not going to use anyone's names or anything like that, but the types of applications are the important things that we want to talk about from a point of view of maybe how people can get moving on a mainframe modernization journey. And with that, I'll let Bob introduce himself.
Yeah, thanks, Larry. So my name is Bob Ellsworth. I'm the worldwide director for mainframe transformation here at Microsoft. I've had a long history with mainframe, starting back in 1971. Worked at Virginia Tech, worked my way through college as a systems programmer, and then spent 30 years working on IBM and Amdahl mainframes. In 2001, I came to Microsoft to help drive improvements to Windows and SQL and Azure to become enterprise credible. I come from the technology side, having 3 patents on mainframe technologies that are licensed by IBM. And in addition, had a passion for virtualization, starting back with VM370 in 1972. So when I was at Microsoft, helped drive the acquisition of our virtualization technology that's used both in Hyper-V and also in Azure. So I've had a great time in addition to building out a mainframe migration practice here at Microsoft, starting in 2008. Back to you, Larry.
Thanks, Bob. And again, I'm Larry Mead. I'm Principal Program Manager. Don't quite have as much mainframe experience as Bob. I started in 1976, so a few years after, but still means I've done a few years on the mainframe. But I've also worked with some other platforms such as enterprise Unix like AIX, Solaris, HPUX, etc. And I've been around Microsoft for over 25 years. And when I came to Microsoft, I thought, well, I'm going to get away from mainframes and be working on non-mainframe kind of systems. But the fact that I had the background on mainframes meant everyone came to me to ask how to do these types of systems, so or how to effectively move them to Microsoft technology. So these days, I focus primarily on the what I'll call the harder workloads to move into Azure. I mean, Ron talked a little bit about having high availability and things like that. So we focus on how to leverage cloud systems to achieve the type of availability, et cetera, that you need, that you were used to on the mainframe. So we have ways that we can do that. And we also look at high volumes of transactions and also low latencies. So all things that mainframes typically do. And so we have techniques to do that, and we do that with various systems integrators and software vendors that we work along with the Azure technology. So that's sort of my background on this. And with that, I'll go on to my next slide, which is really why even look at Azure for mainframes, because if you have a mainframe and you're satisfied that it's giving you the kind of availability you want, the applications are still running. I mean, what are some of the issues? Well, that's a slightly separate topic, which Bob will go into a little bit. But let's say you've decided you want to move into a different environment, like a cloud environment. You need a cloud environment that's available where you are. For instance, your mainframe is probably on premises. So if if, for instance, if you're in Europe or you're South America, Africa, Australia, you don't want to be running a cloud system that's all based in the United States. So, we really need to have systems that are all over the world, and Microsoft does provide that with Azure. And the other thing that I would add is it's not just that we've got systems there. We've got systems that can run highly available, because again, that's a very important thing. So we have these things called availability zones that can run in these systems that are all over the place. Plus, we have systems that can run in sort of edge sites, which that's where we can decrease the latency if you need to have the type of performance that you need, but still communicate in with the sort of the base systems that are running in the regions that have our larger data centers. So all of these things together provide quite a bit of both compute, but also coverage for systems that we find that most customers we do have systems that they could use that would be hosted within Azure. I also want to talk a little bit about one of the other things. Ron didn't mention it, but it always comes up. Okay, going to the cloud, what are the what's my security? Am I going to be in compliance with industries? Well, one of them is having a data center maybe in the country that you're working with, but the other are all these different standards that have to be adhered to. And at Azure, we take a lot of we put in a lot of effort to make sure that we have all these. Now, I'm not going to go through every last a compliance standard that we cover, but the point that I want to make is these things are from all over the world. They're not just based here in the US. They're also in Europe. They're also in the Far East, and we go out to basically, if there is a standard and if it's in a region that we want to cover, then we would go out and be able to meet that. And then I want to bring up one other thing, which is sort of a special case, which is Azure in commercial government. So if you're thinking about moving a mainframe system into that's like federal government based, you need to have you need to get the authorization to do it. It's not like a commercial where you can probably do it within just permissions within the company. You have to get other agency permission to then be able to do that. That's like with FedRAMP is an example of that. And even our commercial platform has accreditation of FedRAMP High. Now, of course, these provisional authorizations, you have to get the specific one depending on your system. But we cover more than commercial. We have a government cloud, and we have more than just government. We have a secret cloud, and we have a top secret cloud. The top secret cloud is still in accreditation, but the point that I'm trying to make here is even the most sensitive systems, we're going to have a place that if you have mainframes to move in, that you can put into Azure. So, these are the kinds of things that make it possible for us to have the infrastructure in place to host this kind of a system. And so, there's a lot of different attributes. And again, it's why are we doing these kinds of things for mainframes? Well, we're doing these things to make it so that you're going to have the same kind of support you need, but you can then take advantage of the cloud as you move in. So within our availability within data centers, our designs is actually for 5 nines. Our supports for being able to work with hybrid clouds, since these things don't necessarily always move at the same time. Microsoft has a global fiber network that we can work within and be able to do that. So there's just the base infrastructure on which your mission critical mainframe systems we can comfortably host in Azure, and are happy to have conversations with whoever is maybe has doubts about that to maybe ease their minds a little bit on how all that can fit together. So with that, I'm going to turn it back over to Bob to talk about the platforms that we cover.
Great, thanks, Larry. So when we think about platforms, and just to get the terminology, so we're all on the same page, we always think of mainframes as IBM Z Series and Unisys ClearPath. Again, the Z Series, the predecessors, is where I have my years of experience. But those, in our terminology, are mainframes. And for mid-range, we really think about the IBM Power Systems, including System I and System P, what was the AS400, now System I. We think about the Spark operating systems and the Spark platforms running variants of Unix. And so those to us are mid-range. And fortunately, we have the partners and the technologies to migrate both mainframe and mid-range workloads. So no matter what your legacy system is, we've got the technologies to support you. Go ahead and go to the next slide.
Yeah, the only thing I would add to this, Bob, is we see all kinds of different sizes. Everything from MIPS is millions of instructions per second, and anything from 100 to over 100,000 MIPS. So that's quite a difference in the size that we go through.
Yeah, we even engaged on one that was 35 MIPS. So it's pretty small systems. That could easily run on my laptop, to give you some context. As we think about the drivers, and for the last 12 years, as we've been helping our customers, like yourselves, with mainframe migration, reducing cost has been the primary driver that we've encountered. IBM mainframes, it's an incredible platform. IBM's done just a great job with it, as Unisys has. But as the other x86 platforms have matured and the capabilities have matured, we're able to run with the same level of reliability, availability, serviceability as you have on the IBM mainframe. And so reducing costs and running the same workload on a lower cost platform has historically been the top goal. In the last couple of years, we've seen just a huge increase as the cloud has matured and acceptance of the cloud has increased. We've seen a focus on flexibility and choice. More and more customers are looking to the future, whether or not they want to have a data center in the future where they run their x86 or their mainframe workloads, and they're choosing to lay out plans to exit the data center by moving these systems out. So flexibility and choice is pretty easy to move x86 or Windows and Linux, and it's a bigger challenge to move these legacy systems, mainframe and mid-range. Agility has become more and more important, especially as we've seen people retiring and businesses needing to adjust to changes in their offerings, their capabilities. And so improving time to market, being responsive to the market. It's difficult to upgrade your mainframe COBOL apps to support changes that the business requires. And it's much easier to update applications in a modern DevOps environment using new tools like Eclipse and Visual Studio rather than the legacy mainframe tools. So that agility and rolling out incremental changes on a daily basis is absolutely possible when you move into a more modern DevOps environment. And lastly, skill shortage. More and more people are planning for their staff retiring that have maintained these legacy systems over the years. And so addressing the skill shortage by ensuring that you have modern DevOps environments, can hire kids out of college, support these legacy systems. And for some customers, migrating from legacy COBOL, assembler, PL1 to Java or C# is one of the goals that they have. So these are the key drivers. Most customers have a little bit of each of these. Next slide. So sometimes you think, well, Microsoft mainframe, what do they have in common? The first thing you probably think about, desktops and Windows and Office. But in fact, as I've mentioned before, we started building our mainframe migration practice in 2008. And we built an ecosystem of partners with tools and services to be able to address whatever complexity workload that you have. It's through this 12 years of experience and bringing the right partners together that we act as trusted advisors to help you ensure that you select the right solutions, the right partners in order to be successful in your migration off the mainframe. Go ahead. So a lot of times it's confusing as to what the PaaS and what the options are for mainframe migration. Every customer, such as each of you, have different existing legacy systems. Primarily, we find ZOS, but we do run into both TPF and VM and Z-Linux. On the Power Systems, of course, both the I series and the P series or the ClearPath, two separate operating systems. Different kinds of databases, both the key databases and also some third-party databases that have been popular over the years. different transaction servers. CICS is most predominant on the IBM mainframe. Of course, the application language. And so for each of these, every customer goes through a process of retiring applications that you don't need, surrounding the mainframe, and using BI and analytics in the cloud or off the mainframe. You're replacing some of your custom apps with packaged apps if what you have isn't delivering the business value that you need. The area that we focus on most of the time is replatforming, rehosting, refactoring. But replatforming is the opportunity to convert from a running system, convert Z-series load modules into x86 runtimes. And we have a partner with a technology that does that and then provides system services for all the system calls. So if you have an application where you have the IP rights, but you don't have the source code, this is a great solution. But they also provide a COBOL PL1 compiler, so you can continue updating applications that you do have source code to. Rehosting is used about 70% of the time. What that means is keeping COBOL as COBOL, recompiling that to run on Windows or Linux, and deploying that in Azure, and then emulating all the other components, such as consuming JCL, emulating CICS or IMS. And then refactoring for those that want to move to a different standard for the development language. Refactoring from COBOL to Java or C# is the path that's chosen. Again, we have partners with solutions for each one of these methodologies, so it's no issue no matter which direction you want to go. And lastly, once you're able to move work off the mainframe and immediately reduce your software cost, since you're paying monthly for those software costs based on peak 15-minute periods in most cases, taking that software savings and reinvesting it to re-envision, re-architect, rewrite those applications you want to make improvements to, or you want to move into a more modern environment. So that's our standard methodology, and we found that works real well, and it's pretty much industry standard, across the different analysts that we work with as well. The next slide. You can go ahead and to the next one. All yours, Larry.
Okay, well, thank you, Bob. Well, one of the first things that people come to and they ask us is, okay, I've got this mainframe and it's got all this compute and it's got all this storage and it's got high performance and all these other kinds of things. So, how do I even go about understanding what it would take to run that in a x86 environment in Azure? And as Bob mentioned, we've been doing this for a while. So we first started looking at how to sort of size x86 type systems based on how they performed on mainframes. So there's a standard benchmark called TPCE, and that was a COBOL version of that was created that then would allow us to take and run it on an existing mainframe. We had a partner that had a mainframe that we could use that we ran benchmarks on, and then we compared that. At the time, it was with HP systems, HPE now. And we found that we got actually more MIPS per core than we thought we would. We thought we might get somewhere between 50 to 100 MIPS per core, but in reality, we were getting in the online, with using a CICS, we were getting 288 MIPS per core. And then for batch jobs, we were getting 170 MIPS per core. Now, this is a published study. It's a little bit older, but it's a published study, and there's also some work that was done by Gartner to discuss about that modernization study. So, these are sort of a reference point of seeing how you can size. Now, we've since run that same benchmark in Azure using more modern VMs, and we've this one we've actually scaled that up to over 25,000 MIPS for running in a configuration with some partners. So we can easily scale to that, and that's getting up to be a pretty large system, because you don't look at the total size of the mainframe when you're looking on how to size it in Azure, because you're really looking more at the logical partitions, the LPARs, that you're running on that mainframe, and then how would they move into Azure. And quite frankly, I've seen a lot of mainframes, and I've seen ones with over 300,000 MIPS, and I've not seen actual LPARs that go much over 30,000 MIPS. So, given that, we're very comfortable that we can size systems within Azure fairly easily that meets that compute power. And then what we would do to, if you wanted to have, say, 300,000 MIPS, you would probably have 10 VMs or 10 compute clusters with something like Kubernetes that then equated to 30,000 MIPS apiece, and hey, all of a sudden you're at 300,000 MIPS. Now it's not quite that simple. I mean, you still have to work in how you're going to deploy it into availability zones and have recovery across regions and other stuff like that. And you want to make sure that your storage is sized such you're getting the throughput that you want. And to be quite frank, that's probably the piece that we spend most of our time on, is making sure we're getting the overall performance that's needed and not just the pure compute. The pure compute's a relatively straightforward process. Making sure that all these other pieces in place is, in Azure is where we, do most of our effort to make sure things run properly. And by the way, we do publish architectures that, and there's some links at the end of this presentation that you can go and look at to see how to, size and deploy into Azure to get this kind of capability. So let's talk about some of the scenarios that, typically we see with customers. And this goes across, both financial services, and that's, I believe, 39% of the mainframes are in financial services. So that's a big chunk. But also retail is out there, manufacturing is out there, healthcare is out there, and government systems are out there. So what we, with the mission critical systems, the things that we, emphasize again are the high availability, the ability to scale out or up, because that's one of the ways of taking advantage of the cloud, is not just scaling up, not just adding compute to it, but then scaling out, which means I could maybe have a cluster of more than one compute entity or VM or Kubernetes node that's running, that's got my power in it. And then that allows me to also have extra availability, because now I don't have a single point of failure in what I'm deploying. So there's some strategies that not only can give you extra power, but also increase your availability. The other thing that we look at is, with these high volume transaction systems, is how to use some of the platform as a service, the PaaS services, to then optimize not just the compute power and storage throughput you need, but also paying for it when you need it. We'll discuss a scenario a little bit later where, there's certain times of the day or during the month where you need more compute and power than at others. What, do you want to pay for that all month long, or do you want to only unlock it when you need it? Some of the other things that happen by going to the cloud is you do unlock other capabilities, and quite frankly, a number of customers think that, oh, it'd be nice sooner or later to do analytics or machine learning or something like that with the cloud. What they find out is it's actually not that hard to do once I have my data in the cloud, because I can then use other systems. I've already talked briefly about bursting to compute on demand, relatively simple to set up within the cloud in Azure. And then finally, the idea of having improvement in my whole ability to develop and test. I can spin up and down development environments as needed. Plus, I can use modern DevOps to then be able to, implement that. And that's usually not something that's done, as easily in the mainframe. And I've already mentioned that, there's a special case within the Azure government and cloud where you can take all of these things and do them there. And one of the key things with the Azure Government Cloud, I should have mentioned earlier, is the commitment to stay on par with the capability that's in our commercial cloud. Now that does maybe lag a little bit because things get deployed to commercial first, but it's not like years to catch up. It's more like in the weeks or months to catch up to capabilities that are in commercial with our government cloud. And so I briefly just wanted to go through a little bit of an architecture here that we have set up that shows different ways that you can potentially move something to the cloud, and it's taking into account either the rehost or the refactor, or actually even the re-envision, the different types of things that you can do. So you can basically look and see that we have these different ways of then hosting it within Azure. One of them, this is partner emulation, where we have partners that can emulate CICS or IMS transaction monitor. They have runtimes that will emulate that. Well, we can then deploy those on VMs that could be in a compute cluster, and then we could host the COBOL, PL1, or whatever the languages, apps that are running within it. So that would be sort of the traditional rehost, and this is ways that this can be done with this. And then it then sits on the types of things that Azure is bringing to the table of our managed disks, our accelerated networking, and in special cases, we can even use the RDMA, which is sort of an HPC type of a system that really lowers the latency if it's needed, because mainframe applications are typically very, very used to low latency, so we want to deploy them in manners that allow that to happen. But if we take a look on the left-hand stack here, this could also be done with a refactor, where we are winding up with Java, and we're taking that and we're then deploying it in Kubernetes in Azure. That would be using AKS, and then we are then being able to have our different types of services, and then load Java applications that are doing that have been refactored rather than having the COBOL. But keep in mind, it's still essentially using the same storage capabilities and network capabilities with it. And then, the bottom piece here is, okay, I also have storage accounts that I would have that would be not my online, well, it wouldn't be my hot storage, but maybe I have cool or archive storage that I would want to have, and I would put that in blob containers rather than managed disks. Managed disks roughly equate to DASD from the mainframe, so that's the online storage of the mainframe. So that's roughly what this is, whereas you could think of the blob storage as things more like virtual tape or tape storage that mainframe has. The other things that I just wanted to point out here is we don't live in a vacuum. So we've got something called Azure Data Factory, which then allows these things to take data in and out as needed. We have pipelines for being able to process that. And then the idea is that these storage accounts can either be within a given region or they can span regions. And then the last piece that I would sort of look here is, we talk a little bit about reimagining. Well, let's say that I want to take advantage of, I want to set up an eventing model rather than use a scheduler to kick off jobs, etc. Well, I could use, the Microsoft event hubs, or I could use I can even use Kafka, the open source type of a system, host that. And this is reimagining how I'm getting that work done. It's maybe not changing the individual programs, but it's saying I'm going to take advantage of the cloud to do these sorts of things. Then we could then also use, if I've got to, again, I'm going to go to financial services. If I have to compute interest for all the accounts within a system, I might be able to do that much more efficiently by applying a Spark job that's running in a Spark cluster like Databricks than it would be to do in a traditional COBOL application, or even one that's been redone to C#. And then the last piece that I'll talk about is the fact that we've got the different options for the data. We see, customers, we've got the Azure SQL database, that's for moving relational data and like DB2 and things of that nature. But we also have our Postgres service. And lastly, let's look at Cosmos DB, which is the NoSQL option. We find that that's something customers see as a viable alternative to vSAM, which is on the mainframe. That's virtual sequential access method. That is where we could use NoSQL, and we can actually sometimes get better performance out of NoSQL than we can with than vSAM had on the mainframe. In fact, we just worked with a customer recently where we were able to set up a cluster with Kubernetes and Cosmos DB, which outperformed what they had something called a Kixplex, which is a parallel sysplex with CICS, and vSAM. So we can actually set up a system where all that outperforms. And then lastly, if you need to have things that are where we need to have backup that goes beyond my normal high availability pieces, this is more DR sort of things, you can use things like Azure Site Recovery to have that go across regions. So there's just lots of options that we can do to give you probably what you need as far as the capabilities, depending on how much you need to have. Now that said, not every customer needs all of these. So that's one of the nice things about Azure is we can pick and choose which one of these things to actually implement. So with that, we are going to look at, a few sort of customer examples with the 10 minutes or so that we have left. And this first one I like to, talk about because one, it's big, over 300,000 MIPS. That's large. That's getting into easily the top 15, maybe the top 10 mainframes that are out there that IBM has. And we have more than one of these, but I'm going to, talk about this particular one. And, setup's a typical mainframe, had multiple, running in parallel sysplex, DB2, vSAM, lots of different systems that are running on it. And that's the key I want to get to is understanding where to start. That's the, the goal is to eliminate the mainframe and the time to do it in, but, how do we decide where to start? Well, that's where we find, going back to what Bob mentioned, it's, one size doesn't fit all. Well, one size may not fit all for a given customer either. And that was certainly the case with this one, where some were more the refactor, some were more the reimagine type of systems. So they did have a goal to get off of COBOL. So refactor was very important to them. So that's sort of the path that was being taken. And the interesting thing is, you remember I was saying that you could actually use new types of, you could rethink how you're actually running some of your processes. And for the batch runs, because most capital markets they might have to burst to do, market open or market close, but they, typically have some more batch type processing. Well, that batch processing maybe could be run more efficiently in something like Spark. As a matter of fact, that is, the direction that's happening with them. Now, again, these are works in progress. They don't happen overnight, and it happens over a period of 5 years. But that just gives you an idea that you don't really have to be afraid of going after large systems, and you can go after them in an organized manner, and then you can attack them, to then move them across, transform them in a manner that makes sense for each one of the applications. And with that, I'll let Bob talk to the next one.
Yeah, thank you, Larry. So just a couple other examples for you. One is a credit card processing organization. And as we worked with them, the challenge that they have was they wanted to expand to other markets in South Asia and in the Far East, but it really wasn't cost justified to be able to install a mainframe in each one of those markets. So instead, what they did was work with Repro and Micro Focus. They used rehosting technology to recompile the COBOL, to deploy it on Red Hat Linux in Azure, to use a SQL Server as the backend database, to basically spin up their credit card processing system and run that in Azure, and then deploy that for each of the countries that they're bringing on board. Now, the beauty is instead of that mainframe cost, which is about $15 million a year for each of these systems, they're able to run this workload in Azure for about $2 million a year. So much less expensive, and allowed them to expand their market to new parts of the world. Move on to the next one. This is a fascinating one as well. It's a Department of Defense. A good-sized mainframe, Unisys mainframe, about 2,500 MIPS, but they're spending a lot of money, $21.8 million a year. Their goal was to improve the aircraft uptime. They really needed to be able to unlock their system off the Unisys mainframe, get to a more modern environment. So they use Micro Focus tooling along with a partner, Stadia, migrate this workload up to Azure, migrate the database from UDS to SQL Server. The vision then is to be able to analyze aircraft maintenance and do predictive maintenance with the AI, machine level, and machine learning and BI tools that we have in Azure. And it's really the next phase. So we think of mainframe transformation as it's a journey. Perhaps the first step is to optimize the mainframe and move these workloads up to the cloud along with the databases, but to continue that journey using Azure services, be able to utilize that data and do it in different ways. And in this case, improve the uptime of aircraft. Go ahead to the next slide. So just to close this off with a couple other details on Azure. Yes, please.
This is Juan Gerber. Well, I just want to also ask you to comment. Spencer from the Department of the Interior had a specific question, and maybe more detailed, but I want to know if you could also offer some general insights. He wants to refactor a software AG natural app using Adabase. He's currently running it on a 1700 MIPS Z196 IBM mainframe. Now, I know that's a fairly specific question. I've copied Spencer's contact information for both of you so you can follow up. Just wondering if you could maybe address it in general terms, and by using this specific real example, offer some general insights to the audience.
Yeah, so Adabase Natural is a fascinating platform. If you're happy, and most customers are not happy with the costs that they're paying to software AG for Adabase Natural and want to get away from that cost burden. If you're happy with Adabase Natural, can find the programmers and want to stay on Adabase Natural, one of the options is to deploy Adabase Natural on Linux and Azure. And we have a number of customers, public references that have used that process to stay on Adabase Natural, but to run it in Azure on Linux instead of running on the mainframe. So that's one option. So Ducks Unlimited is a good example. That's a system in production up in Canada. Another process, if you're not happy with the software charges from software AG, want to get away from that dependence on software AG, then migrating from Natural into C# or Java, and going from Adabase to SQL Server is the preferred method. We have a number of partners that offer that service, such as Modern Systems, which is now called Advanced. They migrate from Natural to C# and Adabase to SQL. Another partner is Blue Age that has a similar capability. We have probably 4 other partners that do that as well. So feel free to reach out to me. You'll see an email at the end of this, or even in the beginning of the presentation. Feel free to reach out to me and be happy to walk through those options with you and help guide you into what's the best solution for yourself. So with that, let me close. We just have a few more minutes left, and you've got these slides, or you'll have these slides, so you'll have these details. And so working with Microsoft and Azure for mainframe migration, as you've heard, we have a long-term experiences in driving these migrations. And based on these experiences, we can help guide you. And it's not just Larry and myself. I'm in the Azure Apps and Infrastructure team, and Larry is in the Azure Global Engineering team. But also we do have from Microsoft Services, they've built up a mainframe migration practice. We have a team that helps with difficult database migrations from the mainframe that are mainframe experts as well. We have an IBM mainframe here at Microsoft, and it's used for testing interoperability between Windows and Azure and the mainframe through tools we have called Host Integration Services. So for the interoperability challenges, we have experts in that area as well. And lastly, when you think of mainframe, you depend on reliability, availability, serviceability on the mainframe. We have features and capabilities in Azure. So when properly architected, you can achieve the same level of RAS as you expect on the mainframe. But then go beyond that with elastic computing, being able to grow and shrink based on your capacity needs, only paying for what you consume, moving into modern analytics, new ways of deploying technology, and also new ways of developing with Azure DevOps. So it gives you a way of looking at how you can continue to advance these workloads. And next slide. this is a good takeaway. You can read this later on. That gives you just some recommended steps for thinking about the mainframe modernization journey. And lastly, we have a set of links to references. On the next slide, the main one is this mainframe migration at azure.com. We just updated the mainframe migration page and gives you some good examples of and links to other resources and information you might need to better understand how we can help you on mainframe modernization and mainframe migration.